Okay, let's evaluate the integral from negative infinity to 0, x e to the x dx. Okay, I see that negative infinity, which tells me it's an improper integral. So, what do I do? Rewrite it as a limit, exactly. X e to the x dx. The limit as t goes to negative infinity, t to 0, x e to the x dx. Okay, great. So again, you're thinking of t now. Now t is a negative number, smaller than 0. Okay, that's just a constant, really. So I can integrate. How do we integrate that? Integration by parts, yes. So all that stuff we just did is all going to apply in here as well, okay? So let's use integration by parts. The u would be x, exactly. Remember, sometimes we like to let u be x, the polynomial part. And then dv is everything that's left. The derivative of x is 1. The integral of e to the x is e to the x. And then I go across and diagonally down in my little table that I made. So what I'm getting is the limit as t goes to negative infinity. So you're going to get x e to the x. And when you have a definite integral, you have to plug in the bounds. T to 0. T to 0. And then diagonally down, e to the x dx. Okay. Yeah. Okay. All right. But we know how to integrate e to the x, right? What's the integral of e to the x? E to the x. So that's really nice now. I can get rid of this integral. So I'm going to get x e to the x minus e to the x. And I got to plug in the same bounds into each one, so I'll just plug them in at the same time. Okay, so I plug in, let's start by plugging in 0, right? What do I get if I plug in 0 to that? Plug in 0, you get negative 1, because the first term is 0, minus, then plug in t. T, e to the t, minus e to the t. Make sure that minus applies to both of those terms when you plug in a t. Okay? All right, so we can go ahead and simplify, distribute the minus. So I get negative 1 minus t e to the t plus e to the t. So now I just need to calculate the limits of each one of these pieces. So I look, this first term is negative 1, that's just a constant, so its limit is just itself, negative 1. So now let's go ahead and look at the last term first and calculate that limit. The limit as t goes to negative infinity of e to the t. Do you remember what that limit is? If not, think about the e to the x graph. y equals e to the x. It looks like this. As you go out, let me move that up so you can see. As you go out down towards negative infinity, what's happening? Going down, 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 my approaches zero. So this limit is going to be 0. So the only term that's left now is this one in the middle for me to calculate the limit of. So let's go ahead and do that one. The limit as t goes to negative infinity, it's really a minus, but I'm not going to care about the minus for now. Sorry. T e to the negative t. This is a product. So what happens, so let's look at each piece. T, as t goes to negative infinity, I'm getting negative infinity, right? And then this e to the negative t, you should think of this as being, so maybe I'll do this first. You should think about this as the limit as t goes to negative infinity, t over e to the t. Oh, sorry. Why is what?
Why is e to the t even to negative t? Because it was negative t.
Oh, it was t. Yeah, sorry. I have a minus in there that I shouldn't have. Thank you. This should just be e to the t. Okay. Yeah. Okay. So if I think about this other part that I'm trying to figure out what happens to, this e to the t here, my power is, we've said it goes to 0, right? That was what we just did. So what I'm getting is negative infinity times 0. That's not a limit we like, because the truth is they're kind of like two competing forces. This negative infinity and this 0, and you don't know which one is overtaking the other, okay? Which one is overpowering. And so we've got to rewrite that. What we really want to do is we want to use L'Hopital's rule, right? To use L'Hopital's rule, it has to be 0 over 0 or infinity over infinity. So I'm going to rewrite this as t over e to the negative t. And now if you look at the indeterminate form, you're still getting negative infinity for the limit on the top. But now the bottom, remember t is negative. So I have negative t, so that would make it a positive power. And e to the t, for positive powers, you're shooting up to infinity. So I really like this limit because now I can use L'Hopital's rule on this limit. Okay? So let's do that. So I'm going to write L apostrophe H so that I remember that I did L'Hopital's rule.
So you just moved the e to the t to the bottom, correct?
Mm-hmm.
Okay, why do you know how to do that?
So the reason why I know how to do that is because originally my limit is a product, right? I have negative infinity times 0. I'd really like, if I want to use L'Hopital's rule, for it to be a division. I can't move the polynomial down, and so I move the exponential down. Yeah. So it's just to get it into that nice form so I can use L'Hopital's rule. That's really it. Okay, so L'Hopital's rule says you take the derivative of the top. What's the derivative of t? 1. And the derivative of the bottom, negative e to the negative t. You're thinking of t as being a variable here. And what's this limit going to be? Well, we've said if you have an e to the negative t in the denominator, I'm getting an infinity in the denominator, right? 1 over a really large number gives me a small number. So this limit is going to be 0 here. Okay. So now I've calculated the limits of all three pieces that I need. If I look back at the top, here I had -1 minus this thing, but I've already calculated its limit. It was 0. And the e to the t, its limit was also 0. So now I can say that this integral that I wanted to calculate, which was -infinity to 0, x e to the x dx, I got -1 for the first limit, 0 for the second, and 0 for the third, so it's -1. And that's my answer.